As we already mentioned, RFID has continued to develop over the last decades. The development has been with the RFID microchips, but also, and importantly, in the supporting hardware, such as the readers, antennas and software, all of which are essential elements of any RFID solution. The biggest advances have taken place with the HF and UHF technologies, and although LF will never become obsolete, the technology gap continues to widen. As we consider replacing or enhancing the dominant LF technology used globally by the animal industry, we should first have some knowledge of why RFID is used at all. Historically, cattle were given a brand mark for identification purposes. Over time, this evolved to become a visual ear tag, printed with a unique animal number. Being visual, the ear tag is susceptible to contamination. This can make it near impossible to read, either easily or accurately. Here an RFID tag can bring advantages as it overcomes the need for a visual reference. RFID captures the data quickly and accurately in a digital non-visual format that can easily be transferred to any digital ecosystem, be that local or cloud-based. Having the ability to check an animal ID using its RFID tag enables it to be captured with lower stress for the animal and less risk to the operator. We now have an awareness of some of the basic, yet important advantages that RFID currently brings to the animal industry. We also see that LF technology is currently dominant, and we know that this dominance, in part, results from its early availability and uptake. Knowing that technology has continued to develop, if we were to evaluate the three main technologies, from today's perspective, would LF retain its dominance? For the purpose of our evaluations here, we will not be considering HF technology. Like LF, HF has a very short reading range, and although HF does have anti-collision capability, mentioned earlier, the limited read range defeats any advantage this might offer. Particularly when we are considering larger farm animals where tags are very rarely less than just a few centimeters apart. In our efforts here to evaluate whether or not the animal industry should be constrained to LF technology for official purposes, we need to recognize that there are at least three perspectives: technical, industry, and government. The next screens try to give an insight into some of the considerations each might make. This is a complex discussion, however, an effort is made to weigh up the pros and cons in a comparative and simplified way. From the technical perspective, we can see that LF has a slow data transfer rate, only a limited read range, and no anti-collision. LF, however, is supported by existing RFID infrastructures and the historic animal RFID standards. Conversely, UHF is not supported by the existing standards. However, it does have fast data transfer, short and long reading range ability, and full anti-collision. It is important to know that LF readers will not communicate with UHF tags and vice versa. On balance, LF is more limited than UHF, scoring only 2 points to 4 in this limited but relevant comparison. From the industry perspective, we can see that LF is below the expected speed of commerce, is limited by its short reading range, and limited to only reading one tag at one time, due to the lack of anti-collision capability. LF technology is already fully integrated and cannot bring additional advantages to the industry. UHF, however, does operate at the speed of commerce, has both short and long reading range capability with full anti-collision, and it also plays well with already deployed UHF infrastructures throughout the supply chain. On balance, UHF brings equal and additional advantages to the animal and supporting industries, scoring 4 points to the 1 point of LF in this limited but relevant comparison. From the government, or should we say the competent authorities' perspective, there's a clear demand from the animal industry for new features that LF technology can't provide. And, although UHF technology can deliver these advantages, without standardization, the use of a UHF tag cannot be for anything but management purposes. With standardization, the industry will be enabled to maximize the advantages of UHF in a cohesive and borderless way. If we consider this situation, we might conclude that historically developed standards unintentionally limit animal industry progress today. Globally, the animal industry is seeking the advantages that UHF technology can bring. The standards agencies and authorities, however, have yet to catch up with and recognize the technology advances. Only by doing this will they recognize the value of enabling UHF, within standards, to operate alongside the historic LF technology. UHF can be used for management purposes already, but only by the implementation of standards will UHF get the global validation it so richly deserves. Reviewing the information shared here and our greater in-depth industry knowledge, it is apparent that the animal industry is best served if both LF and UHF technologies can coexist within a standardized framework. It is great news for the industry, authorities, and the standards agencies that technically, UHF and LF technologies can work seamlessly together and there is no need to choose one over the other. With a standardized framework that recognizes the values of UHF alongside the historic LF technology, the industry will get the advantages it seeks. We hope this information has been helpful. If you would like to continue the conversation about RFID within the animal industry, or if you would like to engage our RFID consultancy services, then please head over to our website at www.hykk-solutions.com, fill out the contact form with a short overview, and we will be pleased to contact you.